Thank you. So today we're going to focus on how to build better data foundations for manufacturing. And this is all wrapped up in a concept called the Unified Analytics Framework. And so we're going to decode the benefits of the UAF and how to build a UAF. As you may already know, my name is Jeff Nepper. I serve as president for Flow Software. This is David Saadi with Software Toolbox, and David is business development at Software Toolbox. David, you have a very rich integration background and history. You've been in this industry for how long?
I think it counts. I'm close on 22 years or something like that. So I've been in this industry since I had hair. And as you can see now, I've lost most of those hairs. So for good and for bad. But enjoy it, and it's a passion.
Yeah, well, thanks for your time here today. Let's get started. So, David, if you would tell us just a little bit about Software Toolbox so that our attendees understand.
Thank you, Jeff, and I appreciate being here and allowing us to share a little bit about our insights. So Software Toolbox is a company, and I'm pretty much sure that's a household name in our industry. So we have very dedicated solutions for specific niche problems in this industrial paradigm that stages from the bottom of the PLC layer to integration to middleware, all the way up to ERP connectivity, for example. And our software stack, or our solution stack, is based on proven, tested solutions, backed up by incredible support, which is backed up by real people, so real technical experts. And that's why we have this company motto of saying that with our integrator clients, with our end user clients, we lean into their industrial data and informational challenges and solve that with our solutions. So that's Software Toolbox in a nutshell.
Great, thank you. And also, if you're not familiar with Flow Software, our entire mission is to give you and your team decision-making superpowers. We get operations. We've been working with operations since 2011. We offer a very mature product that is going to solve many of the pain points, actually, that we're going to highlight today. But I want to say this is not a webinar about Flow Software. This is a webinar about how to build better data foundations. So everything that we're going to talk about today, take as your own. If you want to try to recreate all of the concepts and build it yourself, go for it. If you want to stitch together multiple vendors to create this solution, go for it. And of course, if you want to evaluate Flow Software at some point, we're happy to do that as well. But this is more about education around strategy than it is about a product. And so you're not going to see a product demonstration today, and you're not going to hear a sales pitch for a product today. We're going to talk about how to build better data foundations from a strategy approach that you can take with your organization or with your integration group and get wins from it. Where does our experience come from between David and I? We've seen this concept work, and we've seen it work firsthand with many companies. And I apologize, this is not just companies that Flow has worked with, but also companies that Software Toolbox has worked with. David, I had a typo at the top. But some of the world's greatest manufacturing and then some of the smallest manufacturers, they're all having the same problem though, David, and that is that data integration is costing them a lot. Why is that? What's the culprit?
Look, Jeff, it's the old reality of saying time is money. So the longer you take to do something in order to get an end result, the more costly it is. And, is that sustainable? So this is a very, very interesting topic in terms of data integration and why it is so costly. And I mean, let's explore a little bit.
Yeah. So it always comes back to data silos. And data silos are the things that get in the way of analytics and good data integration work. And often we associate data silos with these proprietary databases that are difficult to access, expensive to license. But I do want today to take a moment that we'll go quickly through and frame up that it is more than just proprietary databases that are the problem. So David, inside of our organizations, we have this concept of siloed ecosystems. Some speak Chinese, some speak Spanish, right? And those are the plants and the enterprises. Two different languages. We recognize it. Yeah, we know it. Like, we all know it. But have we ever thought about why it is? Like, what is the actual reason that we have siloed data ecosystems? Well, it's because we have siloed subject matter experts. Think about who lives in plant world and who lives in enterprise world. They're vastly different in what they do and what their focus is on, and rarely do these subject matter experts really cross over into each other's worlds. It's actually hard enough, David, to get them to collaborate between each other, let alone across the plant versus enterprise.
Very true, because they do speak different languages and they do have different requirements. And so inherently, you're creating your own data silo, but just the type of information that this person or this character or persona is actually after.
That's right. And then where do our subject matter experts do the majority of their work? Inside of the application layer, they've got their own individual applications, 2, 3, maybe 4 applications that they will live their entire professional life working within. And that is where we find those siloed databases. Inside those siloed applications, inside of the silos of our SMEs, which are then cordoned off into their data ecosystems. That creates a problem. And it creates a problem specifically around data analytics, because when we actually start to do our analytics work, we end up creating siloed integrations of that work. We silo that integration work within this SME's app of choice. So what happens, right? The subject matter expert says, David, I have an idea and you're my integrator, right? So you're going to help me in this process, or maybe you're on my team and we're going to tackle this. But here's my idea. If we can take data from this source and from this source, we can create some type of a new calculation. We can have a new insight. It would help us do this better. The very first thing we do after we have our idea is what?
Well, so it's like you said, the idea has to be there, so that needs to be driven by a business case. Now, like we've just explored in the previous slide, there's this plethora of different information sources that is siloed inherently already, depending on whether you on the plant side, on the enterprise side, or a combination of the two. So you need to identify, where does this supposed data point come from? Or data points for that matter, because it could be multiple applications or multiple databases. And then we need to point to that and then work up the stack in terms of doing this integration. So first of all, we need to point to that data sources. Then, like in any good analytical environment, you need to go through the whole cleansing process and validation process of data, because garbage in is garbage out. Going up the stack, you need to then understand, well, how do you need to transform this data or this data into actual information in order to satisfy that business requirement? There might be some calculations or some aggregations or context, which is a word that I particularly like, because time is not the only context when it comes to analytics. There's a whole bunch of ways you can look at the same set of data. And then lastly, once you've done all of this, you need to validate everything. So, if it's, as I say, if you don't take that validation through the value chain, you might end up with a whole bunch of rubbish on the top. And only once you've gone through that complete process, you actually then potentially have something that satisfies that business case. That's from experience and generally how I also see things happening all over the show.
Yeah. And all of that you just described has to live somewhere. And where does it always live? In some application the subject matter expert has chosen for that integration to live. And pick what it is. It could be, it's typically where do they want to visualize the data? So they might say, hey, you know what? Power BI. We're going to do this in Power BI. I know Power BI. And so you're exactly right. Off to the races they go, building those custom integrations. And all that they're doing in this is they're connecting to those sources. They're standardizing all of these different formats of underlying data, cleansing it, adding the minimum context, performing their calcs and their aggregates, validating the results, and we discovered value. Some
sort of an output, correct.
Right. But think about where the cost is in all that. It's not in Power BI. The cost is, right? The cost is in all of that effort, right? To go from data to information is costly. Most of the cost, 80% of it, is in that integration work. And what did we actually make in all of that integration work? We made a stovepipe. We basically took all of that integration work and locked it away inside of that application. But
in order to get from source to destination,
right,
very, very
right. But we did get value, and so since we get value, we do it again, and we do it again, and we do it again, and each time we're adding more applications from more subject matter experts, and again. So by doing it this way, the way that we've arguably done this for 30 or 40 years, this is the foundation that this is the path. I won't even say foundation because it doesn't feel foundational. This is the path that we've gone down. So let's recognize what's lacking from this strategy. We don't have a single source of truth for either data access or for our integration work that we've done. The costly parts is spread out. We don't have real subject matter collaboration, subject matter expert collaboration. Our SMEs are choosing their applications of choice. So they're not really working together in this. They're off doing their own projects. It's almost impossible to have data governance over this because it's spread out in too many places. And frankly, it won't scale. And hey, listen, we see this, we see the fruits of this labor, and it's not bad fruit, right? But we've seen a plant that has this board. And on this board, what do you see? You've got a lot of different reports providing information that someone's trying to act on, but there's a lot of things lacking here. And
absolutely.
Yeah, how do you maintain this? Where's the integration work? Who has access to the integration work that went behind each of these reports? So,
what's the sources, first of all? I mean, what's the calculations that went through? Is the one on the left the same as the one on the right in terms of the fundamental calculation, etc.? That's the real question. I mean, funny story, I've been in meetings or in different plants in my life, and where the meeting room, for example, has all four walls, has got some sort of a chart around it, which shows you today's production, yesterday's production. But, you know, you kind of say, and I'm pretty sure you're going to make a comment about those smiley faces, because I'm just shaking my head saying, what is the fundamentals of a smiley face? Is that good? Is it bad? I don't know. Is it the eye of the beholder, for that matter? So this is not good enough.
How close is a smiley face actually to a frowny face? Is it at 75%, 74%, 5%? You know, and listen, behind all of this are individual stovepipes of integration work locked away inside of applications that we may or may not have access to the work, that the men or women that did the work may not even be available to us anymore. Or we're so afraid of trying to modify any of it and the fact that it might break. Yeah. So worst case scenario.
And Jeff, out of interest sake, what I've seen before is that you will see the complexity of a multi-million tab Excel spreadsheet that probably sits behind that environment, and you break one link and there's 7 stovepipes that tumbles. So there's real life challenges here. This is not the scalable and sustainable way to do data integration.
That's exactly right. And they are super, super fragile, because here's what actually happens. Someone else sees this at enterprise and says, hey, can we get access to that? And so short of taking pictures of it or scanning it or emailing it, if we tried to actually integrate, all we're doing then is taking our stovepipes and trying to integrate it into their enterprise stovepipes. And now the fragility really starts. Maybe we get fancy and we try to send it back down. Hey, look, we know that this isn't sustainable. We know that this isn't the way we probably should be trying to do this, right? So let's talk about more of a library approach. Hey, quickly, if we were trying to create a master library of all works, we would not go build 10 different libraries. We wouldn't spread out 10 different teams and say, go at it, because why? We'd end up with missing volumes. We'd end up with a lot of duplicated works. If we wanted to create one grand library, we would build one grand building, and we would collaborate together, and we would talk, and we would figure out what works we need and what we're missing, and then we would address them. It's not how we've done our integration work, even though that's obviously how we would build a library. It's not how we've done our integration work, because across these stovepipe integrations, we've duplicated all kinds of work.
Absolutely.
And we haven't governed all kinds of work. And we've missed all kinds of potential work that we could have done very easily added along the way to these projects. But we don't, because we're trying to add the minimal amount of contextualization each time to only
just
get
to satisfy that specific requirement for that one stovepipe.
Right. So what if instead we took that library approach? What if our goal was not to land the integration work inside the application? What if our goal was to centralize the integration work into more of a library that would allow us to grow the library slowly over time, project by project? And here's the real clincher. David, what if we stayed independent of the historians, of the SCADA, and even the analytics applications themselves?
I mean, that to become technologically independent to the data source and kind of capture the way you do something or analyze something or calculate something, but irrelevant to where the data comes from, whether it's Excel, whether it's manually entered, or whether it's from an historian from vendor A, vendor B, or vendor C. That would be the absolute ideal, because then you truly divorce the technology from the analytics value add that you're doing into this library approach, which I love the analogy, by the way.
Yep. Well, it's the beauty of being able to take the products that you already have and use them, or inherit products from assets that you've acquired and use them, or to quickly pivot from one analytics application to another without having to worry about losing work. Data consumer, data producer stays independent. Okay, so look, this is what we have now. All of these point-to-point integrations, it's chaotic, it would be hard to manage, it's expensive. We know this layout for data analytics. Now, in the real-time data models, we've established more of a hub-spoke architecture, right? We start to understand the value of putting a broker in the middle of our data consumers and our producers and extending that that model so that anything can connect to anything through a broker. But that's just real time. Some people call it a UNS, but that's just the real-time exchange of information. We can't do analytics with just real-time data. We need massive amounts of raw historical data, transactional records, relational database access, and some real-time, but the majority of this is relational and time series data that we need. So how do we do this and get rid of it? Well, we kind of do the same thing. We just enable hub-spoke architecture for historic data transfer, right? So why doesn't that work typically? It doesn't work typically because of these different data ecosystems, right? We don't speak the same languages in our analytics spaces. Walk us through this concept of, if you would, of namespaces.
Look, so like you've alluded to, I mean, the UNS is a very, very interesting concept, and it's gaining incredible popularity. And that's that hub-spoke kind of approach to say you've got a broker in the middle. If you want data, subscribe to it. If you want to consume data, subscribe to it. So it's a publish-subscribe kind of model. Now, rightfully said, it from experience, it kind of was built up from a real-time data point of view, and real-time data can also contain metadata. So it's not just time value, there's some metadata component to it also, but it doesn't cater nicely for the historical side of things. So people start referring to this concept of functional namespaces based on what the usage of the data is. So if the UNS is kind of the utopia, you might have a real-time functional data space or namespace. You might have an asset-related one, which probably speaks to your asset management component, etc. And then what we're talking about here is to say, well, for analytics, like you rightfully said, you need historical data, but it's not just time context. It is context that's additional to time and a little bit of real-time information in order to create this analytical functional namespace that plays nicely with this whole UNS environment. That's it.
Yeah. And so we're taking essentially our sites, right? And allowing them to have their functional namespace and their ecosystem and our enterprise. And we're creating this hub spoke by having multiple unified analytics frameworks that have their functional namespace and are able to communicate back and forth, right? So it's a higher level namespace for all things.
Focus. Yeah.
The different focus. That's right. But it incorporates those other existing namespaces.
Because remember, they can subscribe to each other. They can share and receive information from each other in order to complement themselves.
That's right. And so let's take a look at the tools. This is where we're going to start telling you now how to build this. If you are starting to say, hey, you know what, this strategy makes sense. Let's look at how it works and what you would want to build in order to get it done. Now, remember, the benefits matter. You're going to get to reuse integration work over and over again. You're going to grow the library over time. You don't have to boil the ocean. You can start small with this. You're going to get really strong data and engineering governance. You're going to be able to control the definitions of calcs and KPIs and events and ensure that the engineering work done once and done right is spread throughout. Highly contextualized and ready to use data. Your subject matter experts will be collaborating inside of the library approach, and again, independence from applications and being able to take your historians and your SCADA systems and make them work with this rather than trying to build solely on top of them and forcing yourself to try to standardize there. All right, the components inside, David. Should we look at them one by one?
Yes, that is now interesting because this is where the wish list comes in.
That's right. So, hey, real quick, if we were just talking UNS in real time, we would have data source connectors. We might have some type of a real-time calculation engine that combines real-time streams into a new real-time stream. You could tie that into a dashboard, and you would have some type of data sync or API to be able to read out, right?
Correct. And maybe looking at the notification engine that in the real-time world is actually alarms and events, for example. So somehow alarms and events needs to also be part of that metadata of that specific real-time information.
So what we need to extend upon beyond just that is more information model, and we'll talk about that, more sense of a higher level of calc engine, a event database, a KPI database, and maybe more historical looking dashboards. Let's talk about it. All right, so the information model, this is a biggie. The information model is going to allow us to step outside of those functional namespaces, allow sites to be sites and use their namespaces, abstract those namespaces, incorporate them, and establish a new namespace for analytics. Let's take a look at how we do that. All right, so here's what you're going to want to create. You're going to create that library approach of templates for both your equipment and your process. So you're going to need profiles of equipment, the properties, what changes, often dynamic, things that never change or rarely would ever change, static. What are the KPIs or the measurements that we want to make? And what are the events for those pieces of equipment or for that process that we want to monitor? You want to define in that template who has permission to modify, who has permission to access, and rules around how long the data is kept. Cool. So in order for this to function as our library, that means it has to live in the corporate environment. So it gets established at the enterprise and then will be deployed out. Let's build one. Simple piece of equipment we can all relate to, a pump, right? So we give it a name. We build a new process, a new profile. We say, this is the name. And let's pretend, David, that our goal here is, remember, we're not just building this to build it. We have a business use case, and we are just simply going to be building here instead of in the application of choice, where we might want to land.
And push it down for that matter. So, I mean, the scenario is, for example, it's a multi-site enterprise and they've got a number of these vertical pumps that's all the same, but running on different sites. So that's the library approach. Build once, use many.
And maybe we build once and then we duplicate this type and modify it and have a second flavor, right? That's the power of this. Okay, so our project says, hey, I've got this idea around pump. If I can get a sense of, I'm going to want to slice by pump horsepower, the amount of flow, maybe the product, horsepower, the amount of flow, and low pressure events. And I'm going to land this in Power BI. I want to get that data in Power BI. So typically you would have connected to Power BI, ingested all the data, done all of this complex, and then isolated that integration work in Power BI to get a result. We're going to do the exact same thing, except we're going to put the integration work here and we're going to feed to Power BI. So what do we need? We need to establish a few static properties around a pump. These are the things that we would have been trying to grab and bring into Power BI anyway. So we'll create a name, we'll call it description, and we'll say, here's the data type. We know we need horsepower, so let's define horsepower. It's going to be an integer. There's the format, and we're standardizing engineering units. Cool. Now, if I wanted to, while I was here, I could further define static properties for a pump, but maybe I don't. Maybe it's the next project where I touch a pump that I add to the library. Either way, some other things that might get added over time or while we're here for an extra 20 minutes of work, nameplate information. Hey, we use Maximo, so let's go ahead and let's link an asset ID for maintenance to this. When did it go into in-service? All things I think we would want to have long-term.
And you can evolve that over time, like you say. That's the required flexibility also, is get quick value from an analytical point of view and add over time.
Right. Have the ability to add over time, right?
Good.
Yeah. All right. And then dynamic properties, process variables, things that change. So we know we need a flow tag so that we can, because we're going to get flow by hour at some point. And maybe we want to understand what the target is of, what should we be making? So again, I'm just making placeholders for this, but I'm saying, hey, it's going to be data type real. There's my format. There's my engineering units. We said we wanted to measure. Oh, yeah, we could add other things, right? We could add other tags, other dynamic properties. Maybe there's a floating vibration sensor that moves around with maintenance. We'd leave a placeholder for that. Pump state, that's a calculation. So we take a dynamic or maybe a static property or both. We write out some type of rule, and then we add conditions. So there's my rule. If value is 0, then I'm stopped. If not, I'm running. And here's what I do if quality is good or bad. Here's what I do if the value is in or outside of band. So conditions. Okay, so what did we want to measure? We wanted to be able to measure total flow per hour. So I need some type of aggregate. I'll take a total of the flow tag every hour. There's the data type. There's the format. I'm going to keep it for 3 years. Define my conditional rules. I could stop there, or I could add a few more. These are my KPIs, right? This is the things I'm going to slice based on time period interval.
And the important thing here, Jeff, is that none of these are real-time values. That's why we're saying this is an analytical framework, because it looks back and it says, well, I don't care about every second. I just want the aggregate of the last hour and store that for future analytics and delivery and calculations, etc. And that's the key.
That's right. My UNS could have got me static properties and dynamic properties and the calculated state tag. This is where we're adding to any model that's been defined, maybe inheriting that model, inherit the model and add to it, because this is where the historical data and the relational data has to come in. Good point. And then on the events, I said we wanted a low pressure event. So there's the definition: start trigger, end trigger. And what attributes do you want to connect or collect around the duration? And then as well as, hey, what if there's a fault? Here, let's define it. Okay. So I've got my pump. Now I can also profile process or series of equipment. Add a 5th category, and now I'm taking pumps and tanks, and maybe it's all flat, or maybe it's nested under another piece of equipment. I'm bringing in the concept of manpower. So who's the people? associated with this line? What's the product associated with this line? Whether it's raw goods in, utilities, or it's inventory that we've made. Once I've done all of this, I take my template, I look to the site that's going to do the work, right? And I deploy instances of that template out to that site. And so now I've instantiated a UAF at the site that has that template and is ready to do the work. Okay. So this is pretty cut and dry data sources. This is the connectors that you need. So if you're building your UAF, you need a way to connect to all of the different flavors of Historian. You need a way to connect to all the different flavors of SQL, all of the different types of real-time sources, and good, solid, easy to use manual data entry.
Absolutely, because we are never, ever going to go away from manual entry. It'll always have a place. But it needs the ability to, I always call it Excel on steroids. So first of all, it needs to be web-based. And second of all, there needs to be some sort of an audit trail in terms of who changed what, because that is what Excel is missing, is who changed what and why and when.
That's perfect. And so now our site is connecting their sources to the template of the profile of equipment. Hey, vibration, cool. It's living in this MQTT server connected. Flow, it's in this Historian. Product we're making is in this SQL database. Foreman is in this SQL database. We're getting in just that simple profile, we might have 6, 7, 8 different data sources now connected. Real-time, historic, time series, relational, manual, right? Okay. Then context, we start adding context. What is the time of site? Meaning, what is my shift schedules? Define shift pattern. What is my production schedule? Does our production day start at midnight? Does it start on Mondays at 6 a.m. and run through, run Monday to Monday? What is the financial patterns? All of this is necessary, not for real-time data. It's necessary for analytics with historical data. I can't do KPIs without a sense of time. I have to have the ability to do many of these calendars per instance, as well as build my own customs. And then context is key. We do not want to go for minimum context because data turned into information is all about context. So we've talked about it before. All the things that you have to do in order to do proper analytics needs an engine to run it. You've got to build this engine. You've got to make sure that you have a way that it'll scale. Anybody can do this in a single instance. You can go build all kinds of SQL queries and write rules in order to do this in a SQL database. The issue is, how do I scale this across my entire operation?
Yeah. So it's not a library approach when you approach it in that way.
Well, and how do I do it so it lives outside of one person's talent or 2 people's talent? How do I do it so I don't inherit technical debt in 5 years? If that person leaves, what do I do? Right? And we've seen that, right? This is what John built. John's not with us anymore. Please help. And then how do we handle late data, missing data? We ran the calcs today, nothing was there, and then it got inserted tomorrow. How do we rerun? How do we version? What if my historian is in store and forward and buffering and I don't have access? You got to be able to handle all of those rules in the calc engine.
Because the point is to have gaps in an analytical platform, because then your analytics are not going to do what it's supposed to do.
Exactly. Now, where do all of these outputs of the calc engine live? They live in the KPI and event database. It's important to note, from a strategy, you do not want to replicate what's already being stored reliably in a historian or in a SQL database. No reason to ingest and replicate data that's already stored and validated in its underlying sources. Those calculated tags, we don't have to store those. We should be able to hold those in memory. And if someone wants raw data for those for a period of time, we run that calculation and provide raw data. So what do we actually have to store? We store the outputs of those measurements, the KPIs, the attributes around them, the events, the event durations, the attributes around the event durations.
It's a subset of calculated values based on the raw data.
And because it's not a huge ask, we could actually recommend doing that in SQL.
Correct.
Much easier. Notification engine. Hey, listen, we've now turned data into information. That's what's happened here in your UAF process. So now it's about, we're pivoting. Now we have to get the information out. This is important. When you build a UAF, it has to be completely open. Nothing that you do inside the UAF can be locked away. So
Correct.
The next 4 tools are all about getting information to people and applications and systems, right? Where are the people already consuming information? That's where you need to connect to. Don't make them go somewhere new. Feed it into where they're already looking. Dashboarding. You've got lots of dashboard tools, I'm sure, but you need a dashboard tool that you can templatize back to the information model. You define a pump, you define a line, you need to be able to define how you visualize those things as part of that information model. Governance. You need a way, since you're combining multiple data sources and giving good KPIs and event records, you need a tool that your management, your higher level team that's used to having to go look 5 different places, to be able to look one place.
Correct. And find the answer.
They've got to be able to share it. Hey, can I print a data table and it not look weird because there's some type of a cursor on the side, right? Or a slide bar.
Correct.
And can I interrogate it? What do we mean by that? If I see a piece of information on a dashboard, here's a production report showing me hourly production, accumulative, and then broken down on the bar chart by hour. And I've got a KPI on there that says my throughput percent change is 7.28%. Hey, remember our picture of the plant with all the information across that board? We need a way that if we see a number, to investigate the number and better understand it. So your UAF dashboard should allow you to click on any number and immediately see the rules. Here's the definition of throughput change. It is daily yesterday minus today divided by today times 100. There it is, equals 7.28%. So there's 2 variables. There's today and yesterday. Here's today's number. Here was yesterday's number. Oh, cool. Let's keep drilling. I'm curious about today's number. How do we get that? Oh, that's the daily sum of the throughput variable or dynamic property. So we're in the information model. We're seeing the piece of equipment. It's a filler. We were looking at a measurement, which was the day over yesterday, right? KPI. Now we're looking at a dynamic property called daily sum of throughput. How did we get that? Well, that was a summation of 2 tags, a good and a bad.
Yeah.
Well, what's the good? I don't know. It's not in my system. It's in the historian or some database that we're connected to. But imagine a world you could click on it and grab the raw data on demand out of that system and display it inside of that dashboard. And that's just what you get. In fact, you even get the name of the tag, and you should get the location of the historian that it's in.
Because the point of this, the data connector understands the historian, so it also brings through the context in the historian, which is the name, the quality, etc. This is super powerful because it allows you to interrogate on the fly from a self-service point of view.
That's right. And because your UAF, when you build it, everything should be connected via an internal API that has awareness. You could expose that or should expose it. And now you've got a full REST API access to all of this information. The model, the raw data from the sources that are connected to it, the calculations, the KPIs, all of it. It's truly data readiness. And that's pulling data. Data syncs, you want to have those. That way you can publish data and you can insert
to other consumers, correct?
Yep. So the advantage of this, you have a world where your sites have their UAF and they're having their collaboration. they're adding value. Those are tiered up to your central library where those templates are managed. And as rules are updated, the sites inherit those rules, but it doesn't break what they've built. Maybe they've put their own flavor on some of it. And your enterprise data team can connect to all of it via one endpoint. And so all of those connected sources at site are now available to my enterprise via one connectivity point. All right. Hey, this is what we propose as a strategy, because frankly, it's going to grow and scale a whole lot better than this.
And stovepipes.
The benefits are clear. We get to reuse the integration work. Every project, we stand on top of the previous project. You've got your data governance. You've got your engineering governance. It's in the library. The data that's showing up is contextualized. You are combining real-time historic data, manual data. You've got complete independence from your historians. You can choose any type of SCADA or analytics application to work with on this, and your subject matter experts are collaborating. So how do we pull it off? We need a strategy, David. And we've already talked about how we're adding value to both plant and enterprise. Let's talk about the easy steps. 3 steps. Decide for yourself if you think this makes sense. If you do, ask yourself these questions. Will it help me scale my analytics effort in my organization? And does it fit our digital transformation strategy? Does it give that horsepower to help make this digital transformation a success? If you think yes on both of those, it's real simple. Your next analytics project, don't do it the old way. Still use the analytics application that you wanted to use. Just shift that work to a library. That means you need to evaluate. Right. Thank you, Don. And that means you need to evaluate potential UAF offerings. Do I want to build it myself? Do I want to go grab 1 or 2 components that are doing this well in real time and then try to figure out how to build the historic piece in or combine them? Do I want to look for one product that can do all of this and just move forward with that? No matter what, remember, it has to be open, it has to be interoperable, and you have to be able to, you can't let your work get locked away. That's the key here. You and I both know that great teamwork drives great progress. And David, why don't you walk us through, this is where from the software toolbox side, from the flow side, we think we have an answer.
And Jeff, thank you for the opportunity here. So, I mean, like we say, just coming back to the previous slide also, you don't have to go there, but it's all about, we are here to explore your business requirements with you. And what we found is then if we talk, we sit with you, we have a business discussion. Typically, what I like to do and what Flo also likes to do is to look at your own data in your own context and start diving into that and utilizing the value of the UAF and Flow on your own data in order to see how we can expose those analytical requirements and build something that's scalable and reusable in future. So, with those activities, we like to sit down and have this partnership type of approach with an integrator, with an end user, with Flow, with Software Toolbox, and say, how do we define an engagement plan to actually move forward and extract that maximum value in the shortest amount of time so everyone can walk away with a big smile on their face?
That's right. And so if someone would like to reach out, let's, as we take questions, let's leave your contact information up as well as mine for questions on the product. I will say Software Toolbox is a preferred reseller and partner with Flow. You guys serve the integrator community extremely well. If you're an integrator on the call and you're trying to say, hey, who will come alongside me and help me figure this out? David is a great contact. I highly recommend him. All right, questions in the Q&A, please. One of the questions that I get a lot, I'll just mention, is from an integrator. What is the benefit? Okay, so I get the benefit of an end user. What is the benefit for an integrator to take on this approach? And the answer that I that resonates, I think will resonate well for you, if that's what you're thinking, is because of the decoupled nature of this. You are creating, as an integrator, your own information model. You're creating your own equipment definitions, your own process definitions, your own KPIs and events, static dynamic properties that are sitting on the shelf for you. Every single project you do, if you go down this path, you are building that library. You will get to a point where you've got nothing else to build. And every project, you're just grabbing the complete work off the shelf and running with it.
That's the utopia from an integration point of view, because you've got a library that covers every single possible scenario from an analytics point of view.
Right. Over time, you might develop your own IP in these measures and events. You can create encapsulated functions of that IP and then deploy these out. You can go back to projects you did 2 or 3 years ago where you've updated definitions in your library and resell those KPIs and those events back to those projects, or whatever your business model. You might just have some engagement where you give that information to help that process. So lots of benefits in that. All right. I'm not seeing any questions coming in from the audience. Anything at all that anybody would like to point out? Agreement, disagreement? Well, hey, silence is golden, and we'll assume that it resonates. Oh, there we go.
They're welcome to reach out at any given sector. There's one question.
Yeah, well, go ahead.
So PJ Geldenhuis, which I'm assuming is South African, looking at the surname, asked, can we do complex genealogies with Flow? So, I mean, I don't know if you want to take this, Jeff. From my perspective, just when I think genealogy, I think about typical MES applications and typically track and trace type scenarios. So in my opinion, Flow is not a track and trace system. It's not designed to be a track and trace system. And for that reason, probably the answer is no. But when we talk about genealogies in terms of data and information, like you've just illustrated with those drill down dashboards, etc., that's an informational genealogy. So then the answer in that context is yes. That would be my quick and short take on it.
Yeah, and I'd be curious on what parts of the genealogy might be in an MES that we could actually bring into Flow as well.
So PJ, feel free to reach out and we can take this discussion further. You've got the emails there on the presentation. Yeah,
and as well to those in South Africa. Yeah, there you go. Buy a donkey.
Yeah, I guessed correctly. Thanks, PJ.
And PJ, also, our friends at Element 8 would be a great resource as well on All Questions Flow if you're in the South African market. Does Flow come with a free trial mode to try and build a proof of concept? Yes, right off the website, flow-software.com. UAF is more depth dimension for UNS. Yeah, so I actually think that the two terms could be combined into just super UNS or uber UNS.
Uber.
Right. The issue is right now when someone thinks UNS, they think real-time data. And so we have to get thinking, oh no, it's falling short of historical data. And so, yeah, I think you could say UAF expands the UNS into something deeper. Good point.
Great.
Proof that you're getting the concept. Thank you. All right. Recording of this will be made available. We'll send an email out to everybody who was registered, probably host it on YouTube. And with that, David, I think we should wrap.
I think it's been fun. Thank you.
Hey, thank you so much for co-hosting this. I really appreciate it. And we're looking forward to more engagements with you in the future, David.
Absolutely. Thank you, Jeff. Really appreciate it.